You know how an AI like ChatGPT can just write a poem, or how Google Translate can instantly flip a sentence from one language to another? It really feels like magic, right? Well, a huge piece of that magic started right here with this one kind of unassuming research paper from back in 2017. It quietly built the foundation for this whole generative AI world we're living in now. So let's dive in and unpack the paper that literally changed everything. To really get it, we have to ask a pretty big question. How on earth did we teach a machine to genuinely understand all the little quirks and nuances of human language? Turns out, the answer was all about solving one massive problem, a bottleneck that was holding AI back for years. So before 2017, the main way AI tackled language was with something called recurrent neural networks, or RNNs. And they had a very specific way of doing things that came with this fundamental speed-killing problem. They had to process everything one piece at a time. I want you to imagine trying to read a long sentence, but you can only look at it through a tiny little straw, seeing just one word at a time. The cat sat on the mat. By the time you get all the way to mat, you've got to somehow remember all the words that came before it. Well, that's pretty much exactly how these old RNN models worked. The paper calls it their inherently sequential nature, and it just meant you could never see the whole sentence at once. And this one-by-one method, it created this huge processing traffic jam. The longer the sentence, the longer it took, and the more likely the model would just forget what it read at the beginning. And you couldn't just throw more computer power at it to speed it up. It couldn't be parallelized. The model was stuck, waiting for one word to finish before it could even look at the next. AI needed a way to just see the whole picture, all at once. And that brings us to 2017, and this paper from some researchers at Google with the perfect title, Attention is All You Need. And let me tell you, this wasn't just a small improvement. It was a proposal to completely tear down the old way of thinking. This sentence right here, this was the bombshell. The authors just came out and said, hey, you know that one word at a time thing, recurrence? Let's just get rid of it entirely. I mean, that's like telling car makers to ditch the engine. Recurrence was what everyone thought was essential for understanding sequences. But these authors proposed a brand new model, the transformer, built on one single powerful idea. And that idea was called self-attention. The plan was, instead of forcing a model to try and remember the past step by step, self-attention would let it look at the entire sentence all at once and figure out for itself what's important. Okay, I know that sounds a little technical, but the core idea is actually simple and brilliant. Self-attention lets every single word in a sentence connect with every other word in that same sentence at the exact same time. This is how the model builds context. So in a sentence like, the robot picked up the ball because it was heavy, self-attention is what helps the model figure out that it refers to the ball and not the robot. It sees all the relationships at once. Think of it like this. It's a big team meeting where everyone can talk to everyone else instantly. Each word sends out a query. It's basically shouting, hey, who here is relevant to me? And at the same time, every other word holds up a key, which is like a name tag saying, here's what I'm about. The model instantly matches the queries to the most relevant keys and then focuses its attention on those words to build a really deep understanding of the whole sentence. So, how does this all work under the hood? Well, this diagram on the left, the scaled dot product attention, that's the core engine doing all that query key matching we just talked about. But the diagram on the right, multi-head attention, now that is the real game changer. See, instead of running this engine just once, the transformer runs it a bunch of times in parallel. It's like having 8 different attention heads all looking at the same sentence at the same time. One head might be figuring out the grammar, while another is tracking who did what to whom. It creates this incredibly rich, layered understanding of the text. Okay, so we have this super powerful component, this multi-head attention thing. Now let's zoom out and see how it fits into the full transformer model, the one that changed the world. And there it is, the iconic, famous diagram of the transformer architecture. Now look closely. See those blocks labeled multi-head attention? You can see exactly where that engine we just talked about fits in. It's the absolute core of both the encoder on the left, which is what reads and understands the sentence you give it, and the decoder on the right, which is what generates the new sentence. This right here, this is the blueprint for almost all modern AI. So this new design was clever, it was elegant, but, the real question is, did it actually work? And the answer was a massive, resounding yes. It didn't just work, it absolutely shattered the old records. Let's just look at the numbers for a second. The paper tested the transformer on machine translation. Now, this BLE score is just a way to measure translation quality. Higher is better. The best models before this, even these complicated setups that combined multiple models, were topping out around 26.3. The big transformer model? It came in at 28.4. Now, a jump of over 2 full BLEU points might not sound like a lot, but trust me, in the world of machine translation research, that is huge. People usually fight for fractions of a point. This wasn't a small step, it was a giant leap. And honestly, here's the kicker. It got these amazing record-breaking results while training way faster. Remember that whole sequential bottleneck problem? Well, by getting rid of it and processing all the words at once, the transformer could finally take full advantage of modern parallel computing. So it was better and it was faster. I mean, that's the dream, right? The transformer architecture just blew the doors off what everyone thought was possible, first in translation and then pretty much everywhere else. Its amazing ability to understand context across huge amounts of text, well, that became the foundational technology for all the large language models that power the AI tools we use every single day. The whole revolution didn't start with some flashy product launch. It started with this simple, brilliant idea: attention is all you need.